Welcome to OC Explained. Let's go over question 27. If you guys want to go over that yourself before we start, pause now and do so, otherwise we're going to get rolling. Alright, the carbon cycle includes processes that release carbon into the atmosphere and places that act as carbon reservoirs. The diagram below shows both major processes that release carbon and major carbon reservoirs. Okay, so the question is this: which of the following disruptions would cause an excess output in the carbon cycle? So, first thing we're going to do is what awesome people do. We are going to highlight a few things, alright? So, carbon cycle, we'll see a picture of that in just a moment. First thing, let's see, releases carbon in the atmosphere. That's where carbon gets put out, essentially into the sky, right? And then the next thing, places carbon into reservoirs. Well, that's kind of like a storage place for the carbon, okay? Alright, so which of the following of these disruptions would cause an excess output? Excess output, that just means like more than normal is getting put out, right? So that's getting put into the atmosphere, okay? So, with that being said, let's go over this picture real quick, okay? Carbon output to atmosphere, so that's getting put out into the sky, not getting stored somewhere. So, organism respiration, that puts out carbon, so pretty much just like breathing out, you breathe out carbon dioxide. Fuel combustion, what does that mean? That means burning fuel. Cement production, that actually puts out a lot of carbon. Carbon reservoirs, this is where carbon gets stored, right? So carbon is stored, quite a bit of it in soil and detritus. Dissolved organic carbon. Ocean sediments store quite a bit of carbon. Terrestrial biota, that just means living things, right, that are living on the land. Marine biota, living things living in the water. Buried fossil fuels, we know that stores quite a bit of carbon, and rocks. So buried fossil fuels actually store a lot of carbon. And just think about that, a fossil fuel would be like oil or gas. When you burn that, you see all that black soot? That's carbon getting released, right? So when it's not burned, it's actually storing quite a bit of carbon. Okay, so let's actually see a picture of it. So this is a picture of the carbon cycle. When you see the arrows going up towards the atmosphere at the top, that means carbon's getting released. When you see the arrows going down, that's an area where carbon is stored, or a reservoir, right? So this is a good picture. If you want to pause and take a look at that, that'll give you an idea of what's storing carbon and what is releasing it. Okay. All right. So let us digress. Let's go back to the question at hand. All right. So let's look at these answers and see what we got. All right. A, the destruction of terrestrial biota. Now, again, remember what we're talking about is which of these would cause a disruption, and then it would cause an excess output. In other words, more is going out than's coming in, right? So the destruction of terrestrial biota. So where's terrestrial biota? Let's highlight this stuff. How about red? Is there a red? Yeah, let's do red. So terrestrial biota is here. So it looks like that's a storage, right? That's a reservoir. So in that case, if you destroyed terrestrial biota, it's no longer storing carbon, therefore it would release it in the atmosphere, causing an excess output. So that answer actually looks really good, but let's keep going just in case. So we will just leave A alone for now. Alright, let's go to B. Increases in marine biota. So where's marine biota? Actually, that's right below terrestrial, right? So if we increase the marine biota, the living stuff in the water, we're increasing the storage of carbon in the water. So that's not going to cause an excess output because it's going to be storing more, right? So in that case, that would not be the correct answer. So let's see, carbon is black. So let's black highlight these answers. So B is incorrect. Bam. All right. All right. Let's look at C. A reduction in the use of fossil fuels. Well, we know that fossil fuels store carbon, right? You know, stuff like oil and gas and things like that underground. They store carbon. They're a large carbon source. Let's highlight that. So when they're underground, they're storing that carbon, right? When they are burned, they're releasing it into the atmosphere. So when it says reduction, that means we reduce the amount of use. So we don't burn as much fossil fuel. So if we're not burning as much, we're not releasing as much into the atmosphere, right? So that wouldn't cause an excess output, right? Because we are not using it. It's still maintaining its life underground, right? So let's carbonize that and make sure that is known to be incorrect. Okay, let's look at D. A thickening of ocean sediments. So, again, which side is ocean sediments on? I don't see it on the left side, but I do see it on the right side. Ocean sediment. So that, again, since it's on the right side, that means it is a reservoir, or it's something that's getting stored. It's a storage area for carbon. So if we thicken those sediments, that means more carbon is getting stored in those sediments. Therefore, it's not getting released if it's stored, right? So again, that would not cause an excess output because we're storing more. So that's another one that is incorrect. Let's carbonize that answer. So it's not D. So really all we have left is A. So let's highlight our answer A in a big storage form of carbon like a tree. Trees store lots of carbon, right? So let's highlight A with a brown tree carbon storing color. Alright, so if you got A, you're awesome. If you didn't, you know it now. Alright guys, have an awesome day.